Hola, ¿cómo están ustedes? ¿Cómo va todo? Soy Danielle Wood y soy directora de un grupo de investigaciones que se llama Space Enabled, donde trabajamos para aplicar el espacio y la tecnología del espacio para improvar las cosas y la vida aquí en la Tierra. Technology from space is one of the key tools that we can use to improve life on Earth. Today we will explore several examples of projects we are doing in the university with partners around the world to apply space technology to make life safer and healthier here on Earth. Every country on Earth can use space technology as one of the tools as part of our greater system to pursue the Sustainable Development Goals. Decimos los objetivos de desarrollo sostenible. Estos son el guía. We have this guide to help us plan what are the key challenges for this generation. This list of 17 goals have been agreed upon by many countries around the world with the help of the United Nations. And underneath each of these boxes are examples of ways to measure, are we making progress to ensure that everyone has access to food, water, education, and opportunities for good work. We also want to make sure that our cities are sustainable and the way that we organize and transport goods around the world is safe. Technology from space is one of the tools we can use to ensure this is possible. In particular, there are 6 examples of technology from space that are already being used to support these Sustainable Development Goals. I show them here. They include satellites to observe the Earth and make measurements of what is happening in the atmosphere, on the land, in our oceans and rivers, and in the ice. We also use satellites for improving communication access everywhere on Earth, satellites for positioning and navigation information, as well as knowledge that we gain from studying how people and objects operate when you take away the gravity. We have researchers who are astronauts living in the International Space Station. How many of you have heard of the International Space Station? Thank you. So there, of course, we have research every day asking what happens to our human bodies, to plants and animals when you take away the effect of gravity. The results of this research also can be used to address challenges on Earth. Finally, we often design technology to improve space exploration. It's ways to help make sure that astronauts have food and water. But this innovation also can be used to design systems on Earth. And of course, here in Chile, it is one of the international centers for astronomy and scientific research about the universe. This infrastructure and education also serves the Sustainable Development Goals. So in my research team, we are asking, how can we best design these 6 space technologies to make sure that everyone has access to them and they are being used in the best way possible to address needs in every country on Earth? And to do this, we need 6 kinds of people. I lead a group with graduate students who are doing master's or PhD, as well as research staff. And we come from these 6 fields: design and art, social science. We are thinking about the human needs. We are also engineers, and we study data science, and we build and operate satellites. With these tools, we can design systems and technologies that make life better for everyone, in partnership with leaders from governments and companies and universities around the world. This is my team. I want to give credit and to say thank you to everyone on the team that helps make this possible. They come from all these 6 areas of design and art, social science, engineering, and data science as well. Let me give you 3 examples of the projects we are doing today to help apply space technology for development. Lista? First, we begin with a project that starts with focusing on design, social science, and data science. In this example, we learn about the satellites that are operated by governments around the world. For example, in NASA, there are a number of satellites, like this one, that measure some aspect of our environment. In this case, we are measuring the rain and snow. And there's a collaboration across several countries to share that data, so that each day on the internet, there are movies that are showing the latest data for global rain and snowfall. And this comes from international collaboration, sharing scientific measurements. Once we understand what's happening with the rain, we can also consider what will happen with the crops. So satellites also provide data about what is happening for living plants, both on the land as well as in the sea. And this gives us information about the health of vegetation. This information can help us answer 4 key questions, and it is particularly useful for Sustainable Development Goal number 15. We often are asking, what is happening in the environment? And how will this environment activity affect the people? ¿Cómo afecta el medio ambiente a las personas? We ask, what are the humans deciding to do in response to the environment? And luego we ask, what information do the people need to improve their decisions? This is common when thinking about the weather or natural disasters or challenges with the biodiversity. So in this example, we are working with an organization that is a social enterprise based in Benin, a country in West Africa. And we are asking how they can improve their use of technology from space to address an invasive plant. The company is called Greenkeeper Africa. They have an important service. They sell tools to absorb pollution in the environment, especially pollution created by vehicles or machines that generate some kind of waste due to oil. Where they are working, this is one of the best ways to clean oil spills or to take care of everyday waste that comes from the daily use of machines. Now, inside these tools, they are actually using a very important ingredient, which comes from this neighborhood, a series of homes built right on a lake. The ingredient they use is this plant called the water hyacinth. It is a beautiful plant, and actually it's coming from the Americas, but it does not belong in Africa. It's invasive. In fact, it should not be there, and when it grows, it quickly spreads over the lake until no one can move with a boat, and it's difficult to go fishing or to move across the lake. So this company, they harvest the plant with people who live in the community, and they convert it into these products that absorb the oil pollution. Now we are thinking with them, can they see where the plant is growing in their lake, in nearby rivers, also in neighboring countries? So for this, we are helping them design a system to use data from satellites to observe the Earth, and from information from platforms in the air, as well as scientific measurements in the lake. We are organizing an observatory of the invasive plant. It will allow them to create maps like this. Here in the red, you are seeing plants and vegetation. And where it is blue, you are seeing the lake. So it is an example of an image using the satellite to find where the plant is growing on top of the water. Eventually, they can make a map like this where all the green areas are showing where the plant is growing now, and maybe we can make an estimate of where it will grow next month. Now we are testing the tools and equipment to take measurements in the water so we can compare what do you see from the satellite with what you see from the ground. And our goal is to say, how do we make it easy for any small company to use this technology from space to improve their activities and make a difference in the community? This next example will focus on satellite engineering and innovations, asking how are we going to build satellites in the future. In this case, we start by asking, how have we been building satellites in the past? This is an example of a satellite built for the US government for understanding the environment. It is very beautiful and expensive. It is an excellent satellite that will last for many years in space. It is the size of a large truck, a camion. And it takes a long time to build and is very expensive to launch. But now also we are seeing smaller satellites. This one also is from the government in the US, from NASA, but it's smaller and you can launch several of these at the same time. Even smaller, you see that there are groups around the world also building these small satellites called CubeSats. How many have heard of CubeSats? A new word. This is an example of a way to build smaller satellites to be less expensive. In fact, one reason I am here today is to learn about the activities for CubeSats here in Chile. Soon you will hear also from Professor Marcos Diaz. He will share a lot more about the activities with CubeSats here. But it was our honor, myself and my colleague, to visit the lab here and to learn about the activities here in Chile and in many countries in Latin America and Africa who are starting to build these satellites right in their own countries. In our work, we want to ask what technology we can use to make it easy to control these satellites when they are in space. And my colleague who is here with me, he has researched to use a very inexpensive material to make the rockets for the satellites. This one is candle wax. It's what we use every day in our homes for the candles, but also it can be used as well as a fuel. And it is something that can be converted into a tool to operate in space and make a small rocket for the satellite. And so we have an experiment that we are preparing, and it is being used first in the lab and also on a special plane that flies in a way that makes you imagine you are in space. And so it shows an example of how we could prepare for this experiment in the future in a satellite. One of my students has been able to go on this special plane flight and take the experiment so that we can test whether the candle wax will operate as we expect when it goes to space. And so she has taken this on a flight along with another team in order to experiment with how it behaves to improve our scientific knowledge about the ingredient. And it means that when she's on the plane, instead of just standing straight, she's able to float just for about 30 seconds. And then we also get the results from the experiment while she is having a wonderful time. In this case, we are testing to see what shape we have when the experiment is operating. It rotates very quickly, and this is an example of how it would operate if we were using the wax in space. Final example is coming from art and social science. I'm happy to be for the second time in Chile. The first time I came was to visit Punta Arenas and travel for one day to fly and see Antarctica with my own eyes. It is a great privilege to see this part of the world that belongs to all of us. And we can ask ourselves, how will we ensure that we are protecting this important part of the world that is for everyone and for no one? Because in fact, we must keep it safe from other humans and from anyone who would damage it. We are imagining a design for a display that could be in museums, especially those in countries like Chile or also in South Africa, New Zealand, the countries that are near the ocean bordering Antarctica. How can we in the north learn from your experience in the south of being neighbors? Can you share with us your experience by sharing at a museum and channeling some of that information also to museums in the north? Can people come as a family and experience results from the science? Of course, there are many scientists studying the ice, as well as the geology and the animals living in Antarctica. And this knowledge can be shared with families and everyone who wants to visit the museum. So we imagine an experience where you see and hear and feel elements of life in Antarctica. It is educational, but also should be very fun to have this experience, to study what happens with the ice, and also to learn how we study space while in Antarctica. We are very fortunate because we can study several questions about space from Antarctica, including there are rocks that come from outside the Earth and land there. There are also various types of life that can only be found in Antarctica, and they surprise us by how they survive where it is cold or dark. Thank you for listening as I have shared these 6 technologies from space that we use to support sustainable development on Earth. Gracias por compartir y quiero regresar muy pronto a Chile. Gracias. Thank you.